In the last presentation, we solved 2 problems on Boolean algebra, and we will solve 2 more problems in this presentation. But before that, I will give you one homework problem in which the function is y and it is equal to a and b, or a complement and c, or b and c. This is the problem, and you have to post your answer in the comment section. If you face any problem in this example, you can see the next presentation, because in that we will discuss the redundancy theorem, and this problem is based on the redundancy theorem. Actually, it is one of the tricks in Boolean algebra, and by using it you can directly write your answer, so that is important. Now we will see the example number 3, in which the function is f and it is given as a or b or c, and a or b complement or c, and a or b or c complement. So let's try to solve it. You can see a or b is common, and let's say x is equal to a or b, so I can write this function f as x or c, because a or b is equal to x, and a or b complement or c, and a or b is again written as x or c complement. And I want to write x or c and x or c complement together, and I will do it because it follows the commutative law. By commutative law, we know that a and b is equal to b and a. So if I have a and b and c, I can write a and c and b. I can shift this c here without having any problem. I am doing the same thing. I am shifting this at this position. So the function f can be written as x or c and x or c complement and a or b complement or c. Now I will use the distributive law, and you can see a or b and a or c is equal to a or bc. A is common, and here you can see x is common, so the function f is equal to x or c and c complement from the distributive law, and we have a or b complement or c. Now from here you can see a and a complement is equal to 0, therefore c and c complement will be 0. So we have x or 0 and a or b complement or c. X or 0 is equal to x. From here you can see a or 0 is equal to a, therefore function f is equal to x and a or b complement or c. Now we assumed x equal to a or b, so I will replace it by a or b. So a or b and a or b complement or c. Again we will use the distributive law because a is common. So using the distributive law, I have a or b and b complement or c. From here you can see this b, c is ANDed with each other, therefore I will AND this b and b complement or c. I did the same thing that we have done earlier, and I will again use this distributive law. This one, a and b or c is equal to a and b or a and c. So b and b complement or c is equal to b and b complement or b and c. Now b and b complement is 0, so a or 0 or b and c, and this is equal to a or b and c. So this is my answer, and you cannot reduce it further. So this is the way to solve the Boolean algebra, and I have used distributive laws. I have used a and a complement equal to 0, it is very important, and also I have used a or 0 is equal to a. Now we will see the fourth example, in which the function is g and it is equal to a or b and a or b complement and a complement or b and a complement or b complement. Again we will use the distributive law, because if I see the first two, in this a is common, and if I see the last two, in this a complement is common. So let's use the distributive law function g is equal to a or b and b complement, and in the same way I have a complement or b and b complement. B and b complement is definitely equal to 0, so I have a or 0 and a complement or 0. A or 0 is equal to a and a complement or 0 is equal to a complement, and finally we have a 0 because a and a complement is equal to 0. So 0 is the answer for this example. And you can also solve lots of problems from your book, and if you face any problem you can ask in the comment section. Please try to solve this homework problem because it is very important, and I'm going to explain how to solve this in the next presentation.